So let's talk about non-proportional relationships. We've talked a whole lot about proportional relationships, and we talked about the fact that in a proportional relationship, y to x always remains constant. Non-proportional, it's not going to remain constant. There's a constant rate of change, but the y to the x values aren't constant, and I'll show you what I mean by that. If you'll look at this example here, they have given us this equation, and then they've just chosen some values for x, and you can really choose any values you want for x, but generally what you'll find is we try to keep it simple with small numbers. Always try to do a couple of negatives, 0, and then a couple of small numbers. So if you input, in fact, let me write that. Input is another word for the x values. That makes y the output. So if you input a -2 right here, -2 plus 2, that is your output of 0. Input a -1. -1 plus 2, that is 1. Input a 0. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So is it proportional? Well, I can look right here. 0, 2. Remember, we said proportional relationships go through 0, 0. This goes through 0, 2 right here. So I can already tell you it's not proportional. I'm going to say, oh, and they said it right here. The graph is a straight line, but it doesn't go through the origin. So no, it's not proportional. So let's look at this other example. Let's see what they've done here. Use the table to determine whether the relationship between the number of cars and tires is proportional. So they've done the same thing that we did earlier, y over x. So this is x, this is y, so they put 4 over 1, y over x, that equals 4. 8 divided by 2 equals 4. 12 divided by 3 equals 4. 16 divided by 4 equals 4. So you can see all the way down, y divided by x is the same. So this relationship is proportional because y divided by x always equals 4. You could also look at it this way. 1 times 4 equals 4. 2 times 4 equals 8. 5 times 4 does equal 20, all the way down. So it is proportional. Alright, so let's do some on our own. Here it says determine if each relationship is proportional or non-proportional. Well, I'm going to check out y divided by x. Okay, 7 divided by 1 equals 7. 10 divided by 2 equals 5. I can already tell this isn't constant, so I'm going to say no, because y divided by x does not remain constant. I mean, I could keep going. 13 over 3, that doesn't even simplify. And 16 divided by 4 is 4. So it's clearly not constant. I knew that at this point right here. Alright. So it says, number 2, make a table and graph the solutions. Okay, so they've given me the input values. So I'm going to go, right here, I'm going to go 3 times -2. I'm going to input the x value with -2 plus 1. And this is -6 plus 1 is -5. Input the -1. 3 times -1 plus 1. 3 times -1 is -3 plus 1 is -2. Input a 0. 3 times 0 is 0 plus 1 is 1. Input a 1. 3 times 1 plus 1 3 times 1 is 3, plus 1 is 4. Input a 2. 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. Okay? Now it's asking me for the slope. Remember, slope is the change in y over the change in x. I can already tell this isn't proportional, right? It doesn't go through 0, 0. So I'm going to have to figure out the change on both sides of the table. Alright? The slope is, I go from -5 to -2. That is positive 3 steps. From -2 to 1, that is 3 steps. 1 to 4 is 3 steps. 4 to 7 is 3 steps. And this is going up by 1. So change in y is 3. Change in x is 1, and that equals 3. My slope is 3. Another thing I'd like you to notice, we'll talk more about this later, is look, the slope right there, the rate of change, it's what goes in front of the variable, what goes in front of the x. This slope you can find right there in your equation. Alright? Alright, so now it wants me to graph the points. I can do this a couple of different ways. I can graph the points like this, -2, -5, which I would go to the left 2 and down to the 5. -1, -2 can go to the left 1 and down to the -2. 0, 1, my y-intercept. Don't go left or right, go up to the 1. Notice that's where it's crossing the y-axis. We'll talk more about that later as well. 1, 4, go over 1 and up to the 4, and over 2 and up to the 7. 5, 6 is going to be up here somewhere, right about there. And I should get a straight line. Yep. There's the graph of this line. Okay. It's non-proportional because it doesn't go through the origin. My slope is 3. And another thing I want you to notice, see these clean points that I drew? Let's talk about slope for a minute because we've talked about rise over run before as well. I go up 3. I'm going to do this little stair step. From point to point, I go up 3 and over 1. 3 over 1. My rise is 3, my run is 1. That equals 3 as well. So there's a lot of different ways to get your slope. Okay? Alright. Look at this one. There's a 1 here, don't forget that. -1x minus 2. Alright? One thing that I'm noticing, look, in front of my x, there's a -1 there. I'm going to go ahead and say that my slope is -1 because here I figured out that my slope was 3 and I saw that that's what's right in front of the x here. We'll double check it here and make sure that works. So I'm going to input a -2, so I've got negative x is -2 minus 2. So that is a positive 2, right? Negative times a negative is a positive. So 2 minus 2 is 0. Now I'm going to input a -1. -1 minus 2. So that's a positive 1 minus 2. Positive 1 minus 2 is -1. Alright? We've got input a 0. So I've got negative, input a 0, minus 2. 0 can't be negative, that's just 0. And 0 minus 2 is negative 2. Look what's right here. Minus 2. 0's partner. Look up here. What was right here? And that was 0's partner. This is your y-intercept. Do you see how we crossed the y-axis up here at the 1? I bet you when I plot these points, I'm going to cross the y-axis down here at a negative 2. We'll come back and we'll see. Alright, then we've got a 1, so I've got negative 1 minus 2. Negative 1 minus 2 is negative 3. And then we've got, plug in a 2, negative 2 minus 2 is negative 4. Okay. Let's see if I do my little peaks, if I get a negative 1 for my slope here. Change in y over change in x. 0 to negative 1, I'm going down one step, down one step, down one step, down one step. So my change in y is negative 1. And up here, I'm going up one step, up one step, up one step, up one step. So, yep. Same thing that I got there. Same thing that was right here. Okay. Plot the points. And you know what? I'm going to do what's called fast graphing for this one. My y-intercept is right here, 0, negative 2. I've already plotted it. I can use my slope, negative 1 over 1, to do stair steps. From my starting point, I go down 1 over 1, down 1 over 1, down 1 over 1, and then I'm going to draw the line, and I want to show you something. Now watch if I plot all of these points too. I'm just trying to show you there's always more than one way to do these things. I'm trying to show you how it's all connected. So I just rewrote all of the points over here as a coordinate pair. So negative 2, 0 is right here. Look, it fell on the line. Negative 1, negative 1. That's to the left 1 and down 1. There it is on the line I've already drawn. 0, negative 2, the point where it crosses the y-axis. 1, negative 3. If I go over 1 and down to the 3, I've already made that point. Right? 2, negative 4. Over to the 2 and down to the negative 4. I've already made that point. So you can plot the points, or later on we'll talk about using just your slope and your y-intercept to do the graphing. But that's it for this lesson.